Good afternoon, everyone, and welcome to the Future of Transport Maritime series. So I'm Isabelle. I'm the TRIG program lead at Connected Places Catapult. Thank you so much for joining us today. This is the first session of a new series of events. And as good things come in threes, we are having 3 events this week, and then it will take place every 3 months. I hope everyone is well today. This Thursday afternoon, we'll talk about last mile delivery and accessibility in transport. But today we are focusing on maritime. So it's a busy week for everyone, but also for the TRIG team. As you might know, that the TRIG 2026 competition has launched yesterday. So yes, it's open for application until the 5th of June. So stay with us until the end if you want to hear more about this great program. Especially that the competition is open to any organization, size, category, including startups, scale-up, local authority, charities, academics. So make sure that you are staying until the end, or that you are joining us next week for the webinar where I will be presenting, but also DFT colleagues will be answering any question about the challenge scope. So today I won't be answering any question around those challenge scope, but you need to register for next week. So I think we can start the content of this session. So in terms of housekeeping, you can see that there's a chat function. You can comment and interact with us during the session, but there's also a Q&A function. So if you have any question, please ask it through this function. We will be trying to address some question as we go if we have time. Otherwise, we set some time aside at the end of the session to answer those. We'll also be able to answer any live questions. So we are together now for a little bit less than an hour, so 57 minutes. I hope you had time to have lunch before, or you are having lunch right now. But make sure that you take some well-being break after to enjoy. Maybe if there's still a bit of sunshine, a little bit, or have a chat with your colleagues, your friends, because it's quite essential to remain effective and kind to everyone. If you're having lunch, please feel free to share what you're having at the moment in the chat function. We'll be interacting with each other. So now, enough talking from me. We will go through the next slide showing access to the application, and then now to the agenda, please. So we'll start with future-looking insight from Mike, who is the People and Digital Transformation Director at Belfast Harbour. He's also board member of our TRIG program. Then it will be followed by 5 innovators pitches who are part of TRIG. And then we'll have some great insight about the industry landscape from my colleague at Connected Places Catapult, Callum Stone, who's a senior consultant, and he brings 10 years experience in the maritime sector. So I think that without further ado, I'll hand over to Mike Dawson, who is going to present the future of transport in maritime. Thank you very much, Mike, for being with us today.
Thank you, Isabelle. Thanks for the introduction, and good afternoon, everybody. As Isabelle mentioned, I'm the People and Digital Transformation Director for Belfast Harbour. It's a trust port based in Northern Ireland. The clue is in Belfast, and we are an organisation for the last 6 years that have been on a fairly aggressive journey in sort of smart port 4.0 technologies, and that, I suppose, has given us some very significant insights into the landscape in terms of maritime innovation and the associated transport around that. In terms of today, I think what's interesting is, from a port perspective, probably a little bit of a laggard in technology in general, particularly a lot of stevedoring operations and the like in ports of sort of medium to small sizes, and there are many of those in the UK and internationally. So the marketplace for those is significant. Not everyone can be Rotterdam or Singapore, and the level of investment required to sort of reach those lofty heights is something that's going to be out of reach forever for ports. Having said that, there are very significant both commercial pressures and environmental pressures to do something in the space of maritime. So it isn't a problem that's going to go away. So what you find is a lot of ports of a significant size, but not the dominant global players. That there's real movement now within the maritime innovation space. So, having said all of that, I've given some examples here of what is actually happening today. So we've had things like wind-assisted propulsion no longer being experimental. Smart Green Shipping's fast rig wing sail system has clearly demonstrated fuel and emission savings of up to 40%. And what you're finding is starting something relatively small and then moving that into a commercial proposition is something that is much more realistic than it was a few years ago, because, as I say, the zero emission, the environmental aspect, greenhouse gases, all of those are sort of focusing people's minds in this space. Shore power and green hydrogen are being actively rolled out in UK ports now. Internationally, shore power in particular has been a real challenge, as has hydrogen, in terms of the ecosystem, in terms of the cost against alternative suppliers today. But there is a willingness to start to embark on that the investments could be made earlier than actually required, or earlier than a return on investment is likely to come. And how we do that is a challenge. But having said all of that, you've got electric charging networks in Aberdeen, you've got green hydrogen shore power in Leith, and Portsmouth port itself is on track to become the first multi-berth, multi-channel charge port. All of that being done with some investment from elsewhere, but with a clear understanding that it isn't, is it going to happen? It is going to happen. It's just a matter of where does it reach that critical mass to come over to be business as usual technologies when the price point comes down. So that's a very active space for most UK ports in particular, but also internationally, you're seeing more of that. And a lot of that's being driven from the demands of large transport fleets, be they cargo fleets, but also passenger vessels as well. And we engage closely with Stena Line ferries in particular, locally, but also from a green shipping corridor across to Liverpool and the likes. So a very live conversation today. Zero emission and offshore wind support vehicles are being built now, being actively built. Artemis technologies are based on the Harbour Estate here in Belfast, taking technologies from the America's Cup and applying that to a range of vessels, both small vessels, but also ferry vessels as well. Tidal Transport have developed zero emission capable vehicles to help offshore wind facilities. And you'll know, anybody that pays attention to the news recently, although there's been some challenge in that space with the international dimension, what you're seeing is still a commitment from European governments in particular to actively pursue offshore wind from future energy independence. MGR Power and Automation completed a trial with Port of Blythe, looking for electric vehicle transfer vehicles to connect and create the ecosystem to help supply or support offshore wind, and all of that coming from 100% green energy being generated. So very, very active space in those vessels. And in my 5 years here, Artemis in particular went from, proof of concept into a number of vessels that they have promoted internationally. And you go out there now, they have a couple of very large vessel hulls that have been delivered for large scale ferry operations to be introduced in near terms. Underpinning all of that is the digital infrastructure. So I mentioned AI here being used to optimize routes and predict asset failures and manage berth allocation and the like. You're seeing real world efficiencies in those, reducing waiting times, for instance, for some of the larger medium-sized ports, 20-30%. What's interesting about that is ports in general, maybe not areas they have great connectivity. Fiber connectivity is a challenge. You're having to dig up concrete to lay fiber when it's often not there. Or you can do like we did, you introduce private 5G networks, but there's significant cost to that. But that initial digital infrastructure, that fundamental fabric that's being put in place is what's been driving medium-sized ports in terms of the use of IoT sensors, real-time emissions monitoring, cloud-based fleet management platforms. And the thing about it now is that's becoming the baseline. The people coming to position their businesses in your port or on your estate, or going to use that, they require that. It isn't a nice to have. It's a baseline. When we started out in this journey 5 years ago, we were set as a real differentiator. That's no longer the case. And what we also found is a lot of companies out there were not in a position to plot to supply ports with appropriate IoT sensors and the like, be it crane sensorization, vehicle sensorization, wind anemometers, et cetera, et cetera. You could go on and on about it, what it is. So there was a real ecosystem starting to be created about appropriate IoTs, appropriate AI tools that could be utilized by ports, reducing friction for their operations and driving efficiencies. Next slide, please. Yep. Left me hanging for a moment. So the next really is looking more at the medium term. And I suppose what it has done is really firmed up what's been happening today. We're starting to get more and more of a direction of travel in this space. And a lot of this comes from the fact that global shipping itself produces 3% of roughly 3% of greenhouse gases, which is just above aviation, actually. But unlike aviation, most of this used to happen in the gray space between national borders, beyond carbon budgets, and only recently are we seeing much more regulation in this space. And because of that, again, people are those entities that Callum will touch on later, some of the organizations in this space, they're being forced down a path, frankly, whether they like it or not. So what you're trying to do is get to a point where the cost of doing business with these various tools is viable for organizations. Within ourselves, hydrotreated vegetable, HVO, and liquefied natural gas, those are bridging fuels used today. So those alternative fuels are starting to get to the commercial scale in the medium term. When we introduced HVO, for instance, within our pilot boats on the estate, that happened 4 years ago. We were leaders in that space, but we did so understanding that there was a higher cost to it. It wasn't prohibitively higher, but it was higher. LNG is the same, but there's a recognition from maritime fleets, but also harbor authorities that this will be the bridge to get us down to the likes of methanol, biofuels, green ammonia. They're all moving quickly. We don't know who will be the winner, or will there be one winner or a number of winners, but we do know that the number of alternative fuel vessels is going to double by 2028. And ports need all sorts of infrastructure to support that, particularly around bunkering. So, the fuel itself is one question. The ecosystem to supply that fuel and store that fuel and measure that fuel in terms of sensorization, like those are all things that naturally come from that. So you go from zero to having a very dedicated ecosystem required to effectively do that. I mentioned shore power earlier. I think it's important to note that shore power, although it appears challenging from a cost perspective today and requires significant subsidy, it will become mandatory. It will not be optional. If you have a vessel in harbor and berthed up, then they're going to need to run offshore power. They will not be permitted to run engines, for instance, in a traditional way. UK government in particular has been actively exploring a requirement for zero or near zero greenhouse gas emissions in that space, so while at berth. So it creates an immediate demand then, not just for shore power that to be there, but smart grid integration, energy management systems, and port side electrification. So again, same thing. It seems to start off relatively small and a simple solution, but actually on the back of that, there's very significant requirements. Carbon pricing is arriving. It's already starting to show its head in a variety of guises today. UK is pursuing both a global GHG levy through the International Maritime Organization and then the domestic expansion UK emissions trading scheme to the maritime industry. And again, an industry that has, in inverted commas, got away with not being labored down with these things. It's something that in the medium term will certainly start to hit hard. So once the carbon price has been set, every efficiency gain for these organizations, including the likes of ourselves, becomes a revenue opportunity, and every inefficiency becomes a liability for those institutions. And a lot of organizations, a lot of ports, not ourselves, but a lot of ports and a lot of port operation business run on relatively tight margins. So that's going to be much more business critical to them as they go forward. One of the big things we've seen and starting to really build a head of steam is around ports becoming energy hubs. And you see this right across UK operations in particular. You see it further afield, but focus on the UK today. So in my view, and certainly our view from Belfast Harbour's perspective, we think it's one of the most underappreciated shifts that are occurring. When you look at ABP's Energy Ventures Accelerator program, connecting its port network with climate tech startups to tackle decarbonization challenges for a whole range of industrial customers that sit on their estate or technology can be used elsewhere, steel manufacturing, shipping lines, and the likes. So ports are being seen as a place of becoming green energy production, storage, and distribution centers, which is radically different for a lot of them. And Belfast Harbour is the same. We have green technology and green energy, creating an ecosystem around that on the back of offshore developments that we're undertaking. We're the same as many institutions out there. But again, that requires a lot of input from technologies that don't necessarily exist today, trying to grow something from the ground up more than anything else. And the last point, certainly on the medium term, is autonomy entering the mainstream. And we've seen that here. And I know what happens in other operations in Felixstowe, Port of Tyne are doing some things in these spaces as well, where you have autonomous and semi-autonomous vessels and remote operated craft becoming standard in defined environments. That includes ferries, offshore wind vessels, harbor tugs itself. And there's a great example actually in Scandinavia of the Yara Birkeland I've listed there, the first fully electric and autonomous container ship. And it demonstrates how AI enables ships to navigate complex routes with very, very minimal human intervention. Much harder to do on a road than it is to do on the water. So that's a very exciting space. In our time here, in the 5 years I've been here, we have introduced a number of trials that have been very, very successful on autonomy in the space. All of that was done with startups. We did not go to traditional organizations for that. So it's a good example of something that is only going to become a bigger market opportunity as we progress into the next phase, which is the long term. So if I could have the next slide, please. Thank you. I'm just noticing that shouldn't say 2025, but anyway. So yeah, when we look at what the future looks like, zero carbon propulsion will be the norm. We actually launch our own port master plan up to 2050 next week, and these are the sorts of items that we are talking about. So green hydrogen and all of its derivatives, be it e-ammonia, e-methanol, synthetic fuels, whatever they may be, they will become the cornerstone for maritime decarbonization, back to addressing that 3% of GHG I mentioned earlier. So with the potential of cutting shipping emissions between 80 and 100%. And that demand for green ammonia as a fuel is projected to grow nearly eightfold between 2030 and 2050. And my own understanding of technologies around this space is often if it gains traction early, it will happen much, much more quickly than 2050. If the ecosystem starts to build up around that. And that usually happens when the commercial opportunity is there. The second point is around, as I mentioned, those autonomous vessels will be the fleet backbone. So when you look at from a safety perspective, human error is responsible for nearly 80% of maritime incidents today. Autonomous vessels can do this better, and they can follow optimal navigational routes, maximize efficiency, lower CO2 emissions, and drastically enhance safety. Those are once we have the solutions in play, port operations will run at this quickly, as will those large shipping organizations internationally. You can imagine what insurance and likes costs for those institutions, Maersk's and likes. And then ports will be fully integrated energy ecosystems, building on what we had talked about before. So developing coordinated visions across UK, across those ports and the various port supporting sectors. Floating offshore wind, something we know when we look out, we see 2035, 2040 in terms of that continuing to grow right through there. Carbon capture technologies, which I know is going to be mentioned, is critical, is a real key part of that solution today, and the storage of that back to infrastructure piece. Green hydrogen hubs at the various sites to help attract entire industrial clusters. So we believe that's something that's going to be created on the back of maritime innovation. The supply chain itself, we see it both being fully digitized and decarbonized together with the maritime industry itself. We think that's critical, and we think when people go out and do their supplier quality checks or looking for suppliers, it's going to be a barrier to entry for them. If they are not in that space, then they won't be considered in the same way. So the carbon footprint of every ton of cargo will be tracked, reported, and priced according to its origin, from its origin to its destination. So how we do that, smart contracts on distributed ledgers will automate compliance, and AI will automate not just individual voyages, but the entire trade networks in real time. And that's something we believe that based on the data projects that we're undertaking today, that we know are happening elsewhere, this will move the ports and maritime industry in general to what was 10 years ago, very, very manually based. And certainly in my time, we have seen that pick up at a very, very significant pace on the back of some investment from some of the larger port organizations. Then the last point is just around the digital architecture of 2050 Maritime. Fully interoperable, open standard maritime exchange connecting vessels, ports, regulators, insurance, and financiers in real time. Every vessel broadcasting performance, emissions, and cargo data, and every port automatically optimizing arrivals, and every carbon credit being automatically verified. So what you see is a range of institutions radically changing how they do business to be much more efficient and effective from their own perspective, but also what that can do from a greenhouse gas, from a decarbonization perspective. And a lot of that will come with the technology being available, the right technology partners being available, and regulation always helps to move the dial to some degree. And that's me on that. So we're on to the next slide then with Callum. Oh, pitches, sorry, Isabel.
No worries. Thank you very much for your presentation, Mike. You're still with us, and we will hear a bit more from you towards the end of the presentation. So if you have any question, please feel free to add. We've heard about the future of maritime. We know that there are already directly, and we will start with the organization Ecomotus. Over to you, Christine.
Okay, thank you, Isabel. Right, good afternoon. My name is Kirsten, and I'm the MD for Ecomotus and the EcoPro. Every combustion engine running right now is doing three things at once. It's burning fuel, it's producing emissions, and if it's a marine engine, that exhaust is going into the sea, the air, the harbour, or into the confined space your crew are working in all day. For fishing vessels, crew transfer vessels, tugs, pilot boats, the story is the same. The engine is the business. So if it's running hard, you're earning. But if it's not running efficiently, you are burning money and creating emissions. And the emissions problem does not go away by ignoring it. The industry answer to that historically has been replace the engine or fit SCR or AdBlue systems, which can cost more than some of the vessels that they're going to be going on. So for a fleet operator running 10 vessels, that could be a critical cost. So we built something different. Rather than looking to capture pollution before it leaves the exhaust, we reduce the pollution actually being formed inside the engine, right at the point of the combustion. The EcoPro connects to the engine air intake. It uses electrolysis to split the water, just ordinary deionized water from a small reservoir on board, into hydrogen and oxygen gas. The oxygen is vented harmlessly to atmosphere, and the pure hydrogen, now separated from the oxygen, is introduced into the combustion airstream before it enters the cylinders. I know what you're thinking, hydrogen on a boat, it's explosive. So okay, here's the important part. The safest way to store hydrogen is as water, so that's exactly what this system does. Hydrogen is only explosive when it's mixed with oxygen and it's above its 4% LEL. At the trace quantities that we use involved and without its oxygen, it's not a problem. So we separate them. The oxygen goes overboard and what enters the engine is pure hydrogen. There's no need for high pressure and no hydrogen storage on board. The presence of pure hydrogen in the combustion chamber changes the burn. It acts in a catalytic manner, making the diesel combust more completely and more efficiently and at a higher energy yield per litre. The burn is cleaner and more homogeneous, so less fuel achieves the same power output. The result, more energy from every litre of diesel, less unburnt carbon, less NOx, less particulate matter, less carbon monoxide, which matters more than you realise to the crew working in and around that engine space, and critically, fewer carbon deposits building up inside the engine itself. The system runs continuously alongside the engine, only operating while the engine is working. Sensors ensure that if the engine is off, the EcoPro goes dormant until the engine starts up and that hydrogen is needed again. Maintenance is minimal. Top up the reservoir with deionized water. That's it. No modification to the engine, no downtime to fit, and no new systems to learn. Could I have slide 2, please? Thank you. There's a lot of text on these, I know. We don't ask anyone just to take our word for it. The Crystal Sea is a 24.5 metre twin rig trawler working out of Newlyn in Cornwall. She's had the EcoPro running for over 3 years, with over 36,000 engine hours of commercial operation. A working fishing vessel, earning her living every week, and over that period she's recorded an average 8% reduction in fuel consumption. At today's diesel prices, that's a fuel saving of over 83,000 for her across 3 years. But here's the thing, and this is what changes the conversation for people. The fuel saving is significant, I get that, but it's not the biggest saving. Because when the combustion is cleaner, the carbon deposits that normally build up inside the engine, in the oil, on the cylinder walls, on the pistons and injectors, are dramatically reduced. Component wear reduces. The oil stays cleaner for longer and the oil change intervals extend, and the engine simply lasts longer between major services. On the Crystal Sea, the engine overhaul intervals have extended by 28% beyond CAT's recommended hours through independent internal inspections and regular oil sampling. In fact, during her recent full engine overhaul, the engineer said the engine was in such a good condition that it could have easily gone for another year or more before needing work. Black carbon in the exhaust down by over 84%. That's why the engine has less wear and the oil remained cleaner for longer. NOx down by up to 74%. Carbon monoxide significantly reduced as well. When you add the fuel savings, the oil and the servicing cost reductions and the extended overhaul intervals together, the Crystal Sea's total documented savings over those 3 years exceeded 235,000. Which isn't bad against an installation that cost them around 25,000. Payback for the system came in under 4 months. So documented real world data collected partly through the TRIG funded monitoring program that we ran on the vessel and continuously tracking fuel consumption, engine performance and emissions across live commercial operation. It sits alongside RENA full type approval and MCA acceptance for installation on commercial vessels. So we've got all the paperwork in place that we need. We've also tested this on road vehicles and generators. The combustion physics are the same in a ship's engine, a freight lorry, a generator, or in port handling equipment. Same engine mechanism, same results. Whether you run fishing vessels or crew transfer vessels, manage a port estate, operate road transport, or you're here thinking about where retrofit sits in the decarbonisation picture, the answer is the same. There's a proven, certified, commercially deployed solution that reduces your fuel costs, extends engine life and cuts emissions. It runs on the engines you already have and it's already deployed and working in industry. Could I have the final slide, please?
And if you can conclude in like
quickly.
20 seconds, please.
The engine that operates today will still be operating in 2035 and most of them will never be replaced before then. And the regulations coming down the line on CO2 and on NOx and on black carbon and particulate matter and carbon monoxide are not going away. The question is not whether these engines need to clean up, it's whether the solution they can actually afford, actually fit and actually operate exists for them right now. We're not asking you to take a risk on new technology, but we are asking you to stop and think. We're showing you a proven system with a certified track record on working vessels in real world commercial conditions. So we all have a duty to do our best to mitigate our emissions and impact on the environment and protect our employees. Our solution not only allows you to do this with the engines you're operating now, but also manages to save you money whilst you do it, protecting your bottom line and your company's future. Sorry if I ran over slightly, Isabel.
That's okay. We'll move to the next page from H2. I think it's Hamed.
Yeah. Hi, everyone. I'm Hamed, CEO and co-founder of H2. So I'm going to next slide, please. Yeah, so our technology called Flexi Capture. We call it Flexi Capture because actually through TRIG program and also CDMC6, we have a chance to just test our system for different fuels, for different ships. And the thing is actually works is just based on using soil sorbents and also process design that we could capture multiple pollutants. And yeah, so actually, I mean, for a trick project, what we actually done, so we just test our system based on combination of mixture ammonia with a pilot MgO. And also for CDMC6, so we actually work on, designing our system for cargo vessels, which then burn in MgO. So, one of the key benefit of our system, as I said, so we actually need, lower space and also material, which actually create lower, capex and also opex as well. So we save a space for onboard ships that actually, you know that the space is cost to ship owners as well. And so, for instance, the main thing that we actually done is, for MGO, for instance, we capture CO2, make it liquefy, and then store on board. And we actually look into some sort of solution to use CO2 as a feedstock for making methanol, for using as a carbon cube concrete, or as a permanent storage. And during the studies that we have actually, so we shown that we proved that our system could actually works with different fuel, with MgO, with ammonia MgO, and the exhaust, in terms of the design that we have, could be clean. And yeah, next slide, please. Yeah, so far we actually validate our systems, and we just filed our IP, PCT, and also filed AIP with the class society. So we actually raised about 500K in non-dilutive fundings, and we demonstrate pathway for reutilization to use CO2, for instance, to capture CO2 to use it as a feedstock for making methanol, for using as a feedstock for concrete as well. And for the next stage, what we actually aim to do is just 2 steps. So commercial validation, pilots, and do the fundraising. So aim to work with different partners in terms of ship owner, naval architecture, shipyards, and also class society to just prove our system, in large scale, and just implement our system, flexi capture on board ship, to see how we actually impacts in terms of financial and also environments. So that's just from our side. Yeah, Ishtox. So completed. Yeah.
Thank you very much. So next slide from over to Jamie.
Good afternoon, everyone. My name's Jamie Marley. I'm Managing Director at Electrified Professional Watercraft EPWC Limited. We've been very fortunate in our short time as a startup to be the benefit of a TRIG grant, as well as an Innovate Launchpad grant, and that enabled us to progress where we are today. So basically, what we noted well on and from some 10 years working in the maritime decarbonisation space was that solutions are required for all sizes of vessels and watercrafts, and there was always been a very high amount of focus on vessels to electrify and create zero emission solutions for vessels of a larger size. But actually, the smaller size vessels that are nimble and used by professional organisations here in the UK have already been sort of overlooked in a sense. And globally, electrified personal watercraft is still in its infancy and certainly not as widely taken up by in comparison to the internal combustion engine versions. So I very much wanted to look at what was holding this movement back, and in our research we realised there's a lot of stigma that goes along with personal watercrafts, which are also known as jet skis, and the operators have to really very much take this into account, as well as high noise, pollution, and short lifetimes. So we've looked at the present state of the art and came up with the idea of developing a drop-in, bolt-in electric drivetrain solution, the e-drivetrain, that would drop into the existing hulls of today's versions and models from the major brands. So with that, we knew that we could really we could really sort of expand on some of the functionalities really that these organizations very much want, the added security and safety, to really turn this asset that they potentially are purchasing to make it really viable and usable. So actually to rethink the trailered version of the personal watercraft and actually redefine it in the sense of actually putting it as a mobile energy source. It also really struck us that the present state of the art is very much designed around, or the jet pumps, should I say, is very much designed around the internal combustion engine characteristics, and we really felt that there was huge gains of efficiencies to really deep dive into that design and really characterize it to the electric drive motor that we're installing. Next slide, please. So, as I said, the journey to date, we've been fortunate to get receive funding from Trigger and Innovate. That's allowed us to progress to TRL 5. We're now starting on water testing, and we'll do for the rest of this year, most probably. That will aid us then to move into further stakeholder trials and demonstrations, and really be able to market it with the added data that we would have built up over this testing period. And so really we're very much wanting to really publicize this solution. We really believe in the benefits to professional users and organizations, all of which have high aspirations for net zero targets and sustainability. And we've been very proud in the sense of being awarded and recognised for outstanding project delivery, as well as for our interaction already with the RNLI, a letter of support for our solution. So where are we going? Well, we're heading towards serial production, but we know that that's some way off, and we're challenged with finances as well as the funding scene at present, where we see there is some areas where we can't enter due to us being defined our definition of our watercraft. And with that, we've opened up dialogue with the Maritime Coast Guard agency, and in dialogue to really sort of help them to understand where we can move this style of watercraft in, and allow it to be or increase the uptake, shall I say. So we're going to be redefining the design, taking everything we've learned from the prototypes, and very much address some of our learnings. Move into marketing and work with the stakeholders, some of which you see on the bottom of the screen. So some exciting times. Very passionate about it, and I'm very pleased to be part of the TRIG program. Thank you, Isabel.
Thank you very much, Jamie. So we'll move to the next slide, and the next organization is MSC International. So Andre, over to you.
Thank you, Isabel. Good afternoon, everybody. My name's Andre Kikucha. I'm a commercial director and marine technologist at MSC. For the next 4 minutes or so, I hope I'm going to talk to you about a couple of things that Mike touched on through his introduction, mainly shore power, port electrification, as well as the concept of turning ports into energy hubs. MSC has been involved in projects and port electrification for about 5 years now. We installed our prototype piezo battery at Portsmouth a few years back, and really the work we've undertaken in this space has carried on from there. In 2024, we were fortunate enough to secure TRIG funding, which really has set us on the path for trying to identify practical solutions to port electrification, and the challenges that ports are facing. So on that, in terms of the challenges here with regards to recharging, vessel electrification, the potential for ports to be these energy hubs, the real concerns that we identified early on were around the fact that ports themselves and the local electricity networks, the grid, they're not really configured or set up to support the kind of entity and organisation that ports are, and certainly not to provide shore power and port electrification in a meaningful way, at least not yet. We found that over the years that things like grid reinforcement can be extremely slow, and we've seen that at Portsmouth in the work they've been doing on the Sea Change project. And it's really expensive too, probably too expensive to make it viable in the here and now. So really the work that we've been looking at is how we can find workarounds and how we can find real practical solutions, energy configurations that solve and deliver shore power, charging, bring renewables together, all without necessarily relying on a grid connection, but certainly to provide sufficient energy that ports can meet their obligations and support the energy transition. Now, through the work we've been doing, some of those solutions have looked at a range of batteries. So the original Primit project looked at soluble lead, lithium ion, and vanadium as the three hot potatoes, if you will, of battery technologies that could support maritime electrification. We looked at those and were trying to develop various analysis methodologies and different solutions that could meet the very unnatural profile that maritime electrification demands. Shore power, you don't have crew vessels necessarily alongside 24/7, 7 days a week, 356 days a year. There's not a consistent demand there. The requirement is for energy and electricity only when the vessels are alongside. So it's very much linked to a very different kind of schedule that electricity companies are used to. So we see the rise of renewables and PV solar and other renewable sources of electricity that can be added into the energy system, so that those peak grid loads, as we call them, can be reduced and accounted for. And like I said, we've been working on this for a number of years. And next slide, please. Thank you. And some of the success we've seen there is we've been working with a number of different types of ports and harbours that reflect larger commercial, or I should say private ports, as well as municipal and trust ports. And we've also identified potential early adopter customers that we're working with through this program of work to see if we can really accelerate the uptake of this technology. But thinking back to the original TRIG project from 2024, that really did allow us to identify analytical pathways and port readiness for the kinds of infrastructure that are required to support shore power and vessel recharging. We identified early on that of the three battery technologies we were looking at the time, soluble lead seemed to be the most relevant in terms of energy density, and other characteristics. Yes. And I'll move on to that as part of the PINS project shortly. But we also had a look at the different characteristics that these technologies, these battery technologies provided, and how they could support the port baseline. And this fed through very much to development of a business model and value proposition, as well as a commercialization plan and timeline to support the onward development of work and technology around this space. And I'm happy to say that, you know, we've been quite successful in that space. We've just wrapped a CMDC6 project called PINS, which is on the right there. We were fortunate in getting a significant larger sum of money, which allowed us to also consider sodium-ion battery technology as a potential maritime relevant battery technology for taking forward in this space, and that has very much come to the fore recently, and I think it's becoming much more clearer that sodium ion is the way forward in terms of maritime electrification from a lower cost perspective, a lower energy density, and of course it doesn't necessarily suffer from a thermal runaway like lithium ion batteries do. So that's kind of very quickly, that's been the work we've been doing over a number of years. We have great plans and great interest from a variety of quite large ports in this space. But for today, really the point of us being here is to see if we can find further trial partners, delivery partners, as well as with an eye to CMDC7 and ZEVI2, think about demonstrators, pre-deployment demonstrators, and even for those organisations or those ports that perhaps missed some of the early adopter work we did, you know, we're happy to work with any port that is interested in exploring maritime electrification. And with move, thank you. It's great.
Thank
Cheers.
you, Andre. Let's move to the next page, last but not least. So aerogel, and I'll hand over to you, Antonio.
Yeah, good afternoon, everybody. I'm Antonio Malfenci-Fierro, Head of Growth for Aerogel Core. Pretty much, we've just completed a TRIG project, and it was based on developing an insulation material for clean fuel systems. One of the issues you have with clean fuels is that they are required to be stored at a certain temperature. If that temperature changes, or it gets too hot, or it doesn't stay at a cold temperature, you lose fuel, and that creates cost. And so obviously better insulation materials reduce that fuel loss, thereby saving you money. At the same time, many insulation materials currently are not recyclable, and they're made with hazardous materials. So what we really did is we developed a new insulation material, an aerogel material. Aerogels are very, very light materials. If you've ever seen a photo of a feather with a material on top of the feather, that is an aerogel. It's mostly composed of air. At the same time, aerogel materials are very good acoustically and thermally, so they can also be used within a ship between cabins for HVAC and machinery spaces. So we won the award for the project with the greatest growth potential. We're very pleased. Without TRIG support, we wouldn't have been able to even explore this use case. We've moved to TRL3, lab scale proof of concept. We've had some very promising results. We're 11.3% lower density than PIR. That's an insulation material. And thermally, we're a lot better. In terms of acoustic absorption, we're 33.15% better than melamine foam. We have a significant improvement over the 1,000 to 3,000 hertz at a lower thickness. So if you have lower thickness insulation that does both thermal and acoustic, you can save weight. If you save weight, you save fuel, you can reduce emissions, and you reduce operational costs. At the same time, our material can be combined into a thin panel. It's flexible, it's multifunctional, and it can be formed. And there's a thermal and acoustic value in one layer. And this is useful for complex geometries. Next slide, please. In terms of where we're going, This year, we're focusing on a prototype and a partner demonstration plan. We're applying to the Clean Maritime Demonstration Round 7. We're also raising external finance, and our priorities really are to focus on de-risking our technology, strengthening our IP, some strategic hires. Obviously, these are funding dependent. And after that point, from 2027 to 29, we're looking at demo trials on vessel, or with hydrogen storage or OEMs. And then we're looking at qualification and supply chain readiness and manufacturing scale up. Obviously, we need to do some validation evidence, patent applications again, and some key hires. What we're looking for at present, we're looking for OEMs. If you're a ship owner or operator, we'd like to talk to you. We're also looking for integration partners. There's a big market here for retrofits of existing vessels. And we're also looking for investment. Again, my name is Antonio Malfenzi-Fierro, Head of Growth for Agile Core. My details are on the slide. This project wouldn't have been possible without Trig, so a big thank you to Trig. Fantastic program. Thank you very much, everybody, and look forward to the rest of the presentations.
Thank you very much, Antonio. So now we've heard a lot about the future, some very interesting solutions that are already being developed, and now we are moving to the second part of this session, which is giving some useful and practical tips to innovators that have never targeted the maritime sector before, so they can understand the current landscape and hear how to break into that industry, Trig being one of the solutions, obviously. But without further ado, I'll hand over to Callum Stone from Connected Places Catapult. And next slide, I think.
Yeah, thank you very much, Isabel. Great to see some of the solutions previously as well. I'll jump in just and power through as quick as possible with with one eye on the time. You'll see a fairly watered down stakeholder map here to fit just about everything we can on the screen and still have some of the text visible. But I think it's fair to say maritime often feels quite unfamiliar, not because it's particularly niche, but rather because it doesn't really behave like a single industry. It's a system of independent roles with responsibility that's distributed across many different types of organizations, and the complexity comes, I think, less from the technology and more from how it's organized, where you'll find a sort of fragmented system where the ownership, operation and regulation sit with many different stakeholders that all influence that system in different ways. So at a global level, you have the large shipping companies that move goods between continents, of course, although they do operate internationally. Their decisions directly affect the UK, which ports they need to call at, what fuels their vessels need to use, and what infrastructure is going to be needed locally to supply that. In addition to them are your UK and local operators. Some examples, as you can see on screen, ferries that move people and vehicles, tugboats guiding ships safely in and out of port, and some of the specialist vessels that were mentioned earlier as well, particularly by Mike, that largely support things like offshore wind farms. And these operators are kind of mostly rooted in place and often closely tied to coastal communities and local jobs also. As you'd imagine, ports are centric to that system. They manage the land, the infrastructure, the safety of operations, and they often the interface with local authorities is very much ran through them. They're not just these kind of transfer points. They shape how maritime activity fits with towns, energy systems and transport networks. And then, of course, I think the only thing left to cover on there is the regulation that ultimately underpins most of the rest on there. Some rules are set internationally, others nationally, and that mixture is essential for safety as paramount, but also means that progress depends on the alignment with regulation rather than a more of a, I guess, unilateral action. Next slide, please. Again, even more crowded slide than the previous, this one. So just to run through quickly, this takes a bit of a step back as a stakeholder structure from Maritime, particularly on its own, and looks at the wider decarbonisation system that both the transport system and Maritime sit within. I think the key point and message from this is that the decarbonisation system is not something that any single sector can deliver in isolation. Of course, it's a system that only works if different parts do move together. You have the energy providers who determine what low carbon power and fuels are available, while areas like finance and insurance decide what can actually be built. The tech providers translate ambition into real sort of solution, and in Maritime that flows down to them needing to integrate safely with existing vessels and port infrastructure as well. Of course, government set the rules and incentives around that, and often that comes into play across both UK and international levels. The reason I think this wider view matters particularly is because maritime decarbonisation can only progress as fast as these surrounding systems will allow, really. So decisions about energy, finance, policy and skills are made that are made outside of maritime specifically do then directly shape what is realistic within maritime, and that's why innovation within this specific sector often works best when it's positioned as part of a broader decarbonisation effort rather than I guess a standalone challenge. Next slide, please. I have just on this page just tried to point to some of the main stakeholders that are particularly active in the sector at the moment, some of which you'll of course recognise, and I've chosen based on kind of appetite for innovation and being pretty newsworthy for that of late. So you've got from the top going down, the likes of Maersk, strong example of how global shipping influences what happens locally, with them being the second biggest shipping company in the world by market share, only second to MSC, and that was only a bit of a recent change. But yeah, decisions taken by large international operators do tend to shape what UK ports need to provide, what fuels are prioritised, and how quickly the innovations that they look to use can scale. Bibby Marine represents something a little bit different. They're a UK-based operator with that deep operational experience, and organisations like that are critical for innovation because they understand the reality on board the vessels that they have and what charterers of their vessels need. They're often the bridge between kind of new ideas and what actually is proven to work at sea, and they've been innovating, I think, since the 1800s. Stena Line again demonstrate how ferries operate frequent, sort of predictable routes, which makes them ideal test beds for new fuels, electrification, operational changes, and you'll often see what works there can inform wider adoption. The IMO underpins everything else on this slide, really. It sets the global rules that the vessels have to follow, regardless of where they're based, and innovation in maritime will succeed when it aligns with those global standards rather than trying to work around them, really. So again, just for sake of time, I'll jump through to the next slide. And just on that question, I think CMA CGM, yeah, just third, I think, in market share now, behind Maersk and the likes of MSC. I've seen an increase in order book of theirs as well for methanol and other sort of future fueled vessels that are due for delivery in the coming months and years. So just on this big projects and trend slide, my last one. For, I guess, innovators new to transport, it's important to stress that maritime innovation isn't just about vessels and fuels, and I've referred to the port side, as others have as well today. In the immediate term, the ports are a major opportunity space, in my opinion. The shore power and electrification kind of aspects to and will contribute to reduce emissions quickly, but increasingly pairing that with things like AI-enabled planning, using data to optimize arrival times, things like berth allocation and energy use can really help to cut fuel burn and congestion without changing the vessel the vessels themselves. And I've gave some examples in here as well that you'll be able to read on screen. Moving over to the next 5 years, we'd expect to see more structured demonstration projects, and that can include cleaner vessels on predictable routes, but also growing use of AI for safety, condition monitoring, maintenance, things of that nature. And we know, of course, Maritime generates a huge amount of operational data, and there's huge value in turning that into making better decisions. Further ahead, there's a trend towards Maritime becoming part of I think there'll be a trend towards Maritime becoming part of a wider digital and energy system, has been also referred to before. That port starting to act as energy and data hubs, not just physical assets, but you'll see more advanced computing, including things like quantum in the longer term, and that has potential in areas like complex routing, energy optimization, and supply chain resilience as well. So the examples that I've included here, I've tried to put in there to show how maritime decarbonisation is already moving across different sort of time horizons. In the near term, projects like the Port of Aberdeen Shore Power Scheme demonstrate how ports can cut emissions today by electrifying vessels at berth. In 5 years, hybrid vessels such as those being introduced by Brittany can show how cleaner operations on predictable routes can scale using the existing infrastructure. And then further out, a place like the Port of Dover, using quantum-inspired optimization highlights kind of how advanced computing could come into the thinking, and how they could help manage complex port and transport systems more efficiently in the future. And that is it for myself. I believe I'm handing back to Mike.
Thanks, Colin. Yeah, very quickly, just a little bit on the procurement process, everybody's favorite topic, including my own. But just with regard to the ports themselves, I think if we just focus on those, there's quite a different approach in terms of procurement within those port environments, both in terms of some of the barriers, but also in terms of the opportunity. So trust ports themselves are statutory bodies, not public sector, but they make money, and then they don't distribute the profits to shareholders, they reinvest it. So I refer to it internally as virtuous capitalism, as much as that can be. But it also gives those ports a much longer investment horizon and a different appetite for innovation. But they have to then operate under those public accountability frameworks. So a lot of our procurement has to be done through, or at a level, has to be done through utility frameworks and the like. Having said that, we will make investments and bets on quite small, innovative projects based on the long-term horizon. So it's not the immediate ROI. It's important for some things. It isn't always important for technology bids. But what we have to do is make sure, and as it says there, procurement is defensible, transparent, and demonstrates value for money. So we can make some bids in those spaces. Private port operators, strictly commercial businesses, their procurement is much faster in principle, but it's driven by ROI and competitive positioning. Decisions, though, are often centralized, and they're a little bit more risk averse, is what we have found in dealing with them. And what is interesting, I think, if you have an in those environments, so if you're solving a real problem or a pain point for an operations person or a port superintendent, whatever it may be, that might be the way to leverage that internally to help take advantage of, I say, the more nimble approach to procurement that they could undertake. So from an implication for sort of startups and smaller businesses, any pitch to a trust port or trust port-like environment should lead with public value, environmental impact, on long-term partnership, because that social sustainability piece is critical to those environments. So when you do that, I think that's something you can add your pitch onto. And if you're pitching to those strictly private operators, you focus on payback periods, efficiencies, and ease of integration to systems that exist today, but also sort of that future roadmap of systems. So I just wanted to flag that up from a procurement point of view, because the approach is quite different. And that's all I have to say to that. So back to you, Isabel.
Thank you very much to Callum and Mike for this insightful content. So because we are overrunning, I think we've been a bit ambitious in terms of content. This is the first time we are running those sessions, so we'll be learning from it. So I just wanted to draw your attention to the competition that is open at the moment. I'm not going to go through all the slides, just the first one maybe, so you can know what TRIG is. So TRIG is an innovation funding program that supports board early stage ideas, aiming to solve real-world transport challenges, equipping innovators with engagement and program support activities that help them refine their solutions. So it's a long-standing partnership between Department for Transport and Connected Places Catapult. And we, through TRIG, we support all type of organization, including local government, industry, academia, investors, and then we are supporting our alumni community to grow even further to the project that we funded. So if we can go to the next slide, I think you have the, and again probably towards the end. So now application are open. If you want to scan the QR code, it leads you to the open call page where you can find all the information about the competition. Please register as well to our webinar happening just next week. So you will be able to hear a bit more about the program and all the challenge scoping. So you know where you fit within that program. And we are looking forward to receiving a lot of application from innovators, not only innovators that are operating in the transport industry already, but also just innovators that can make a strong impact on the transport system. So I'll stop here, encourage you to apply and join our webinars. And again, we are running similar session on Thursday, one about accessibility in transport, the other one about last mile delivery. So I also encourage you to join us on Thursday. It's very important for us to receive some feedback about our events, so please complete the survey. Also the opportunity to know if you're interested to hear more about one of the solutions or to hear a bit more about the program. So please complete the survey. This is very important to us. Again, thank you very much for joining us today. I hope you enjoyed the session, and I look forward to hearing from you through application or through interest to engage with our innovators. Thank you everyone for speaking as well, and have a great rest of your day.
Thanks, everyone.
Thank you.
Thank you. Bye-bye.
Thank you, everybody. Bye-bye.